You fixed it. You fixed it.
Ah! There you go.
There you go. You're welcome.
Murder. All right. We need to talk. We're gonna talk rocks. Let's do some geology type stuff. And I know some of us flipped through the book a little bit.
Yeah,
I do. Grab my notes here. How old is the Earth?
20 years.
How old? How old? Let's put it this way. How old is the universe as we know it?
20 years old.
It's like 17 billion.
Oh yeah, it's in the right. You're in the right ballpark. I have about 13.5 billion.
3 billion.
So about 13.5 billion years ago was the Big Bang.
Yeah.
BYA.
Yeah. So
Big-
with the Big Bang.
Bang.
Hey.
So some people are a little confused on the Big Bang. The Big Bang wasn't like just a giant explosion or a black hole going supernova type thing that makes the universe. As far as we know, all matter just appears infinitely everywhere, right? The problem is, all the antimatter appears everywhere, instantly everywhere as well, right? However, what happens when you have antimatter and matter? They destroy each other, bam, they're gone, right? The reason why we're around today is a tiny, tiny fraction of that antimatter became regular matter. And so we're just the leftovers in the universe of all of that stuff that became. So, the first few billion years, stars formed, right? The stars, over billions of years, the stars actually like went supernova, and they spewed their star-like contents everywhere. So for the first half of the existence of the universe, as far as we can tell, it was pretty much just like hydrogen and helium were the only elements out there. And then after that first generation, so about, what is it, maybe 8 billion years ago, we have a second generation of stars. Draw a sun. So there's a second generation of suns. So this is where our solar system comes from. We're in the second generation. And the cool thing is, instead of just being helium and hydrogen, since we had all these stars that spewed their guts everywhere in the first generation, we have bigger, heavier elements, right? So we have the rest of the periodic table to play with, including things like iron and silicon and carbon and all that, oxygen, all that stuff. So the solar system forms around the same time Earth forms. How old's Earth?
13.5.
Nope, that's the universe.
Same thing.
I have 4.5 billion in my notes. So Earth forms, what did I say, 4.5 billion years ago? We have Earth, but it's not Earth like we're used to.
Big old flame rock. What is that? Volcano?
Yeah, it's a volcano.
Okay.
Yeah, there's volcanoes on the surface, like super volcanoes, right? It's all molten, right? It's super hot. Why is it hot? Because it just condensed. It's being hit by asteroids all the time, right?
Got no atmosphere, got no magnetic field.
Also, there is a little other thing.
Little.
What? So this is Earth. We had, or like, actually, not even Earth. This we're gonna call Gaia. Did I misspell it? Is there an I in there somewhere? G-A-E-I-A? Gaia?
These,
Is there an I? Did I misspell it?
Mr. Markup, these little volcanoes I'm putting all around the Earth look like waste power plants. Yeah, me too.
And there was another body called Theia. This is our current understanding of the moon. Yeah, so Theia comes in. Does it get captured by the Earth? No, they slam into each other and collide.
Isn't Theia supposed to be as big as the sun? I mean, as big as the Mars?
Yeah, Theia's about the size of Mars.
Big as the Mars.
Yeah, anyway, Theia slams into Earth, right? Releases tons of energy, releases tons of material, it flies out.
Mark, I want your Discord. What did it say?
I'm on a bunch of Discords. Okay,
What did it say? I don't know.
It was a World of Warcraft.
anyway,
Hey.
eventually, the matter from the Theia-Gaia collision coalesces into the moon. Gives us our moon. There's moon. And eventually the Earth begins to cool, right? I don't know why I made it green. It's not green yet. Make it brown, I guess. But it begins to cool off. Here's a question. Where does the water come from?
Oh, what is it? I think the video says
From Mars?
underneath the.
Yeah, the most of the water that we theorize is actually in the rock itself. And then it heats up, becomes basically water vapor, hangs out around here, and then it just rains and rains and rains and rains once it cools down enough. And that lands on the surface of the water, the Earth. Just because it came cool enough.
How could it become cool enough if there's a bunch of volcanoes and lava and stuff?
It took billions of years. Like it cooled off quite a bit. And keep in mind, the Earth isn't necessarily like cool. It's just the crust is cool, right? Where we are now. Another theory about where the water came from, which is very, very plausible, is that it came from meteorites and/or comets that came in, right? So during this period, we have these little like things coming in, dropping off. Theia may have brought water in, but most of the water most likely just came from the rock itself.
But
How? Because water molecules can be bound to the rock molecules, and then they can be removed.
That's crazy.
Yeah, it is crazy. What about the salt in the oceans?
That came from all of the rocks.
Yeah, that also came from the rock, right? However, you have to have liquid water in order to get the salt out, right? If you were to like take salt water and boil it in a pan, does it become saltwater vapor?
No,
No, it just becomes regular water vapor, right? The salt is left behind on the earth.
because water has a lower boiling temperature, I think, minimum.
A much lower boiling point, yeah.
Water equals rock.
Cool. I forgot to make it brown again. Okay. So the water came from the rock. The salt also came from the rock. But it came from the rock through erosion, right? So as the water eroded down, it brought the salt. I wrote NaCl. What does NaCl mean? Sodium chloride, yes, cool. Word salt in this case. All
Wow, that shouldn't be salted.
right, draw a picture of the Earth real quick. Or draw a quick map. Look at this. Here's Alaska. Here's Mexico.
It did not look like that.
Here's Central America.
Sorry, boy.
It doesn't have to be great.
That's better than me, alright.
Mexico, Florida. Look, I'm pretty good at the U.S. Some islands over here. Oh, I forgot Alaska.
How dare you?
Here's Greenland.
How do you forget
There's
all that?
Iceland. There's Europe. There's like a dangly bit for Scandinavia.
Whole thing memorized. Look at this.
There's, put Italy in there.
You made South America way smaller than it actually is.
Whatever, right? It's not to scale. It's just a rough Earth. Put India in here.
Make the map, Mr. Markov.
Did I make the map? Yeah.
Did you
Here's Russia.
You're forgetting Australia.
And Antarctica.
Australia's
Alaska's
looping back around over here. Yeah. I forgot Japan. Is the rest of Russia? Oh, it should be over here. Anyway, the point being, how many oceans are there?
There are 4.
Let's label them. What are they?
Atlantic.
Atlantic Ocean is where?
Well,
Okay, this is Atlantic.
actually, actually the South Ocean, I'm pretty sure, is now considered an official ocean.
So there's the Atlantic Ocean. What are the other oceans? Pacific is over here. Just ballpark it. Relax.
South Ocean?
What was that?
Antarctica Ocean somewhere. Antarctic. I don't know.
I believe there's an Arctic Ocean in the South.
There's an Arctic Ocean.
And the Indian Ocean.
And an Indian Ocean.
I'm pretty sure.
Okay, here's the deal. You're right. Let me be patient. Okay, there are 4 major ocean basins: the Arctic Ocean Basin, the Atlantic Ocean Basin, the Pacific Ocean Basin, and the Indian Ocean Basin. These have their own basins, which just mean they're lower and visibly lower if you look at like a contour version of the world than all of the continental land around it, right? The Atlantic Ocean Basin is lower, water flows into it, that's where the ocean is. Right? Same deal with the India Ocean. There is a 5th ocean. It does not have a basin. What's the 5th ocean?
The South Ocean.
The Southern Ocean or the Antarctic Ocean?
Yeah. Finally, some
Nice.
representation for the Southern Ocean.
Here's some.
Yeah, so there is a Southern Ocean and Atlantic Ocean. So be careful,
Yeah.
okay? If somebody asks you how many oceans there are, you can say 5. If somebody asks how many ocean basins there are, what do you say? 4. Okay. Don't get confused on that. That trips up a lot of people.
Well, why would somebody ask you?
Why would it? Somebody what?
Ask you.
Oh, if, I don't know, you had a test in a marine bio class or something.
Hey, wait, I didn't know that.
What? Did you not draw that yet? This is just the world.
Yeah, I don't know the world.
Okay, well, hurry up. Leave another 10 seconds.
10 seconds.
6, 7, 4, 3, 2, 7, 4, 2, 1.
Okay.
Pretty much close.
Okay.
Yeah.
Do you guys remember the layers of the Earth? Psh, let's see if we can draw it. Oh, look at that. There's an Earth. There's a crust.
So
Psh,
weird.
yeah. Super good.
I could.
Okay.
There's the planet.
There's a crust.
Are you drawing this?
Yeah.
Okay.
No, it doesn't have to.
So, where are the dinosaurs exactly, Mr. Hunt?
In the crust.
They're in the
They got on rocket ships and flew away. Oh, they're in the crust. Why can't they be in the crust?
They're
in the crust or on
They're in the core.
How did dinosaurs die?
Oh yeah, remember there was that movie
That might
where
be-
that's where the dinosaurs are. They're in the center of the earth because it's hollow.
Yeah, it's
That's where
all
the dinosaurs are.
That's also where Hitler.
The big
Well, no, Hitler isn't there anymore because he died in one of the tribal
Okay,
conflicts.
the rest of, guys, shh, there's 3 main layers. There's a crust. Do you remember the other 2 layers? The mantle and the core,
Yeah.
right? So those are our 3 main sections. Yes.
Do we have like a bunch of evidence that the dinosaurs were killed by meteors?
It's grown a lot, yeah.
Or is it just like someone said it and now everyone's like, yeah, that's it?
No, the evidence is piling up. Why?
Because the aliens could have done
Yeah, it could have. Aliens can send a meteor.
I don't. It isn't even theorized that the meteor was what majorly killed most dinosaurs. It was vitamin D deficiency.
Okay. Within the mantle,
They had died from the winter caused by the explosion.
there are some divisions. We have the inner mantle, the outer mantle, and then we got the core. There's an inner and outer core as well. We won't worry about that. But two terms which are kind of different. So there's crust, mantle, core. This thing is weird.
Also, there's lithosphere.
There's lithosphere and asthenosphere, yes. So the lithosphere is the crust and the outermost bit of the mantle here. What does litho mean?
I don't know.
Means lift.
Like a monolith?
Oh, what? Big.
Mono is one, so a monolith is?
Pillar. One pillar.
Object.
Oh, it's one what?
Base.
What about a
Stone.
yeah, stone, lithography. Litho means stone.
One rock.
So a sphere here just means a spherical thing, right? So lithosphere is the stony sphere. This is solid.
I'm a genius.
It's
I'm a genius, guys. I knew it was stone. I didn't just.
The rest of the mantle
is goo.
is called the asthenosphere. So we can spell it right. A-S-T.
Mr. Marquette, do you think you could survive the asthenosphere? He could live there?
Probably not.
I'm not asking about like humanity in general, just you. You personally.
Yeah, me personally. Have you ever read that book? I had a little book when I was a kid where like he gets it, like makes a ship that can like go into the earth through the center of the earth and stuff.
There's a movie like that. The things were stopping moving and then everything was falling apart.
I just remembered this really cool Wishbone episode where these dudes go to the center of the earth. I like Wishbone.
They broke in like center of the earth because of magnetic field was dying.
Whoa! You know what asthen means? I looked it up. You know what asthen means? Asthen means weak. 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 It means weak. Asthen means weak. So asthenosphere means a weak sphere. What do you mean by weak? What do you think they mean by weak?
It's always like jerking.
It's liquid, yeah.
So if you go deep enough in the earth, you can technically swim to the pole.
Okay, hold on. Here's the deal. It's liquid, but liquid doesn't necessarily mean like particularly thin liquid.
So
right?
like
It's under really high pressure. It's kind of more like honey, right? Or you've seen magma, right? You just pour out magma, right? It's not gonna be like, right? Like water or alcohol or something. It's gonna be like it's liquid, yes, but it's thick and viscous. But it's able to be.
by swimming in gel, you can technically swim.
How instant is death in the
But that would be like
asthenosphere?
It's not instant. It just boils your outside, and then you sit there as this cooked individual for a while. Okay, let's draw a picture of the Earth here. Hold on. Well, no, not a map of the world. I'm trying to get a couple things going on here. Okay, we're gonna go that. They're gonna do this zone. And then
Anyway, we have like a 10% chance to live.
Hello.
That's a pretty high chance.
10%.
Yeah. No idea. I'm tired.
okay.
Yeah, my first period.
Mr. Marco, is 10% a big percent?
Depends on what you're talking about.
Yeah.
Of living.
10% of death, that's huge.
See?
No. 10% chance of life.
Okay, so remember how they were talking about like the undersea, volcano type things, right? Those undersea ridge and the undersea ridge where the continents are spreading apart, right? Why are those continents spreading apart?
Because atmosphere.
It's actually because of gyres in the mantle. What do I mean by gyre? What I mean by gyre is basically just a flow of something, right? If I were to heat up water, if you notice water when it's heating up, it doesn't heat up like evenly, right? If you heat up the bottom, water on the bottom has to go upward, right? So it churns constantly. So that's what's happening here is there's a churning motion inside the mantle.
I feel like a few years from now, some like really rich dude is just going to find some way to speed up continental drift.
Make his own island.
Yeah, just make his own continent, and he's like, "This is my country."
Okay, so with this churning, if there's a place where the mantle is pushing upward, right? It's going upward and then also outward. You not only have basically the magma, right, coming up near the surface, but you also have this top part is spreading apart, right? So this is like the Mid-Atlantic Ridge is a classic example of that, the one that Tom Scott was swimming around in, right? The two plates here are spreading apart from each other, right? And it's caused by this upwelling basically in the mantle, okay? So then this other plate is coming over here. What's it gonna do when it collides with the land plate? They're gonna push on each other. Which one is heavier?
The bigger one.
That one.
The ocean plate or the land plate?
The one
The
on
ocean
the
plate
right.
is actually heavier.
Yeah.
Yeah, the rock itself is actually made out of heavier things, so it goes down this way. That causes earthquakes around Alaska, but it also creates a giant trench, right?
Is that how the Mariana Trench was formed?
Yes.
Awesome.
Yeah, that is.
Hey, your recording thing was just a 22-22.
Ridge, and this is a trench. So this is where the Marianas Trench is. There's also a really big trench off the coast of Alaska too. This is part of the continental plate, like North America, Australia, whatever it is, Asia, but it's still underwater. So therefore, what is this section called? Does anyone know?
Michelle.
Yeah, the continental shelf.
Shell. Let me keep books.
And this here is the continental slope.
What is in those jars?
Slope.
Those jars.
Oh, there's a bunch of jars. There's lots of things. And then over here we have dry land, right? This is where like trees and people are. Okay, so you guys all did that. You guys got different densities for different minerals, right? Which minerals were the heaviest?
Iron.
The volcano.
Probably not.
The hematite was. The pyrite.
Lots of ice in them.
I'm not sure about the pyrite. I know you can't see
Wait,
it,
which one was?
but I had it up earlier, and you have access to it, right?
Which one was
And the basalt. As it turns out, the crust of the ocean, or the plates that make up the ocean, have lots of basalt, and they have lots of hematite.
Is that the whole reason you had us do that? So you
Yep.
can tell us that?
And then the lighter minerals are up here. Yeah, but it was a fun way to experimentally do it.
Thanks for the help on the homework.
Oh yeah, math is fun. We. No.
Oh, okay. Alright, see you later.
Say, have a good one.